let's recap the last, how to do the calculations for exercise number 4. We're trying to find acceleration differently than we did in exercise number 3. So exercise number 3, we were trying to find instantaneous velocity at a single point. We found a bunch of average velocities, we plotted them versus the time. Then we got the slope of the curve. Because there were average velocities from the equation, we had to double the slope to find the acceleration. So she should have done that and completed that in exercise number 3 and got a value for acceleration. Now let's compare it with a different method. It's using another kinematic formula. Again, the kinematic formula number 3 for exercise number 3, we use kinematic formula number 4. For exercise number 4, we're using kinematic formula number 3. It's kind of funny, actually. So let's write our data down. I'm picking the middle trial. You're going to have to do this for each of the distances. You find an average of the time. So let's just recap. So for d is equal to 3, we've got T1s 0.0271, 0.0269, and 0.0271. And for T2, the time trials, we got 0.0153, 0.0152, and 0.0153. So the first thing you want to do is take the average and standard deviation of those times. So on your calculator, I'm going to switch to stats mode. Then I'm going to do 0.0271. What I do is I put it on stats mode. I don't want to find the average and then go back and find the standard deviation, because your calculator will do both at the same time. It saves you some time. So the average is 0.02703 seconds. And again, for when you're writing down your data page, make sure the position you put down is 0.0001 seconds, because the smart timers are precise to the 1/10,000th of a second. And the standard deviation on that one is sigma. Oh, no. We want this n-1. Okay, so it depends on what type of calculator you have, but you have to be slightly careful, and so that's the standard deviation. Writing down the standard deviation. When you have a calculator, this one right here, it's a TI, but it's probably a little, it's not one of the, probably one of the ones that you have. There's 2 different standard deviations. See the n-1 and then the n. So which one should you pick? Now, if you have a calculator like this, you want to pick the n-1 because you're doing sample standard deviation. That -1 corrects for the fact that you're only sampling. I mean, there's an infinite number of data that we can take, and look, we only took 3 trials. If you really wanted to have a great standard deviation, the regular standard deviation, you have to sample, you have to look at every single sample. For instance, if you're looking at voter polls, if you want the regular standard deviation, you have to ask every single person that is that's a voter, and that would be the regular standard deviation if you got every one of those answers. But of course, we don't do that in real life. We can't. We only do a couple thousand at a time out of hundreds of million. So that's called the sample standard deviation, when you take a sample out of the entire population. So another way, if you have another type of calculator, you may see S and then sigma. The sample standard deviation is the S. You don't use this one because for lab experiments, we always do sampling. I mean, we can't take infinite amount of data. Okay, having said that, let's actually go ahead and do 0.0153, 0.0153, and then you have to enter them all in. And then the average would be 0.01527, and the standard deviation is the sample standard deviation. It's really small, of course, 1, 2, 3, 4. All right, so it's tiny. It just means our data is precise. It doesn't mean that it's accurate, but that it's precise. So now that we have the time, we can find the velocities. So V1 would be 0.015 meters. Remember, 1.5 centimeters is the distance between the photo gates. Velocity is distance divided by time. So V1 would be 0.015 divided by 0.02703. So you've got 0.555. three significant figures, I guess. And then we have V2. Again, there's two photo gates, so they have the same distance, but different times because the velocity will be higher at this point. 0.015 divided by 0.01527. So remember, you're going to do this for the other two. You're going to do this for the other two distance measurements. I'm only going to do this 0.3 right now. So now all I have to do is plug in the equation. The acceleration then would be v2 squared. So 0.9823 squared. I'm just going to write it out. Of course, as long as you use parentheses, you can put it in your calculator. But if you put it all at once in your calculator, just make sure you use parentheses because it's very common. I see lots of people making errors typing these things in. And then on the bottom, it's 2 times the distance. So the distance is 0.6 meters. So it's the distance is 0.3 meters. Multiply that by 2. From the formula, you get 0.6. So all we have to do now is do our final calculations. So 0.649 minus 0.30803. Divide that by 0.6, and you get your acceleration of 1.095 meters per second squared. And let me see. There's, yeah, that should be okay. Cut it off at that point. I know we have a lot up here, but for the bottom one, it's we go to the 1/10 of a centimeter point. Okay, so that's our acceleration. And you can compare that to what you got from exercise number 3. And now what we're going to do is go on to exercise number 5 to find another way to find acceleration.